Welcome in the section number 7, that is the last section in our Scala programming course about parallelism and concurrency in our code. So, in the first video, we'll understand the difference between parallelism and concurrency. There will be a quick overview of those both concepts. Second video will be about parallel collections. We'll see motivations for parallel collections using the par method. First video will be about futures. So we'll be revisiting monadic concepts with futures and we'll be using Futures API. Fourth video, we'll take a quick grasp at the actors and how Akka is implementing actor system. Finally, we'll be looking at the comparison between Java and Scala threads and thread pools. And this is a first video in which when we do a quick review of parallelism versus concurrency. So we'll see what a concurrency is, what a parallelism is, and we'll compare both techniques. So what a concurrency is? That is the first question. So concurrency is a first step to parallelism. You cannot achieve parallelism without concurrency. But what concurrency do? You can have concurrency with one core CPU, but there could be multiple threads, but all of those threads will use the same core CPU, but still you need to have some kind of a scheduler that puts values and puts data to process by multiple threads, but underneath there is one CPU. So that is a concurrency. Once you have scheduler, threads, and concurrency, you can have parallelism. So parallelism is when you have multiple cores, but you cannot have parallelism with one CPU core. So let's compare concurrency with parallelism. So we have some processes, threads, and execution time, and you can see that there is only one CPU core because only one operation is processed at a time. So you have different tasks, different threads, but when the thread first is processing some data, the thread second needs to wait because there is no CPU core available to process the data. You have parallelism, and this situation is different. Here, for the parallelism, you have multiple CPU cores, so those CPU cores can process your task simultaneously. So we have multiple threads, and every thread can have own core that is processing data in the same time. And if you have mutable data or shard structures, the problems can arise when you have parallelism. So we can have exactly the same code that has multiple threads but works in a concurrent environment with one core, and the problem will not arise because there is no concurrent modification of data and everything is within one CPU core. So parallelism needs multiple CPU cores. You will have some free threads, for example, or queues for that specific thread, and there will be pool of threads. Every thread will process task, delegates that to the CPU core, and that thread can be pinned with CPU core but doesn't need to. One thread can use multiple cores, one core as the processed is at the beginning, then it can switch to the different core and so on. But ideal situation is that thread will be pinned to specific core because it will have caches warm and ready. So once we understand concurrency and parallelism,